We talked a little bit last week about how to take words and turn them into mathematical expressions. So we had that big old long list of things on fancy words for add, subtract, multiply, divide. Well, there's a few more fancy words to throw out there right now. And what we're going to do, so we're going to come up with some of these fancy words for when we're dealing with an inequality, when the arrows start working here a little bit. So you'll notice there's a couple of different types, because you see these arrows, and I've added a couple of things in. You'll notice I've put X's in on the left for all of them. And I made a couple of little notes here to help me remember where everything goes. Because just because an arrow points left doesn't necessarily mean it's going to be less than every single time. It depends. At this point, it's going to be, we're going to take a peek at how to figure out where the arrow goes, what direction it goes, and how that affects our answer. So whenever, the safest thing for us to do is always to have X on our left. Because then if the arrow is pointing at X, like it is here, that means it's less than. My values are getting less. Okay? Maybe you have less, I don't know, less M&Ms or less money or something like that. But if my arrow is eating the X, okay, that's greater than. It means my values are going to be getting bigger. And the only difference between these on the left, these two guys, and the ones here on the right, is that little arrow underneath saying that that value is going to be included. So what you see here and here in general setup is going to be the same. Just the same way that in general these two are the same. Okay, it's just, do I include that last number? Okay. Now, let's actually get into these because it makes it a little bit easier to work with when we actually start to look at it. So I start looking at these, and I say, okay, between two numbers, and we don't talk about those up here at all, they're down here. The only thing I've got to remember if I see the word between is that the number with less value, the smaller number, goes on the left, and the larger number is going to go on the right. So like if I say between 6 and 10, I'd put the 6 here and the 10 here, because 6 is smaller than 10 is. So if I actually get into trying to deal with this, I can go, okay, now let's see how this works. It's a lot easier when you actually get into it. So for instance, I'm going to start over here at B and then come back to A. I'll explain here in a moment. X is less than 5. Okay, so I write it like I say. Okay, X is first. X is less than, I see right here that the arrow points at X. So we'll do that. Okay, X is less than 5. And if we're using this kind of chart here to help us for the first part of it, that's okay. Okay, you don't have to be an expert 5 seconds in. You'll get used to it as we go along. But the key word here is that the is at the start of it. Because you'll notice is. If that is not in front of your less or greater, that's something a little different, which is why I waited for this one until second. 9 less than X is 5. If there's no is in front of it, that less than just stands for minus. So that key word here again, key word is. If you see that in front, that's when we get to the arrow. So let's see, 9 less than X. Now I got to think about this for a minute. 9 less than X. Is that 9 minus X or is that X minus 9? I don't remember. If I want to take 9 away from X or have 9 less, which one would it be? So I'm taking 9 away from X in the first one?
No.
But I appreciate your willingness to actually try one of them. Okay, for this one, if I want to take it away, okay, so like if I said you had $10 and I was taking 9, that'd be 10 minus 9. So it'd be X minus 9 Then is, we talked before, is the magic word for equals. 5, and you're like, yeah, those do kind of look different, okay? But the key again is, it's all about, is my is there? So what we're going to do on this sheet, for some of them here, and you'll notice this up at the top, and I hadn't done a good job of writing this. Okay, and our homework check number 2, okay, this is going to be our 5th assignment, and notice the homework is going to be the evens, so like 2, 4, 6, and just kind of keep counting that way. So here's how this is going to work. I'm going to help you out on some of the odds here, and then we'll see how this is going. So let's see. Number 1, Roberto weighs no less than 125 pounds. No less, okay? So now, Roberto, you could use an R to stand for him. If you want to use X for all of them, you absolutely can do that. But we're always looking for those key words. So, weighs no less, oh, no less than, which actually means, oops, come back down a little, which means he's at least 125 pounds, and he can be more. So if I can be more than something, okay, I'm going to be greater than that. And that's all I have to do. There's nothing to solve. It's just writing that out. Mary has at least 8 goldfish. She may have 8. She may have more than 8, because when it says at least, she may have 10, she may have 20, I don't know. But that's what we've got to work on with this, is kind of getting used to those words. And again, using the chart, there's nothing wrong with that. Josh has at most, okay, here's at most. Ooh, that's less than or equal to, and that's true, because I might have $10 to spend, I might have less. And we said less than would go to the left. Because if you think about it, if I plug in a number for J, let's say I plug in 7. Is 7 less than 10? Yeah. Okay. Uh-oh.
Harty, can you pick up, please?
All right, so we talked a little bit about at most. Let me bump this up a bit. All right. Here's where the keys start to come in. Here comes that is word again. So a number, and we talked before about a number is any variable I want it to be. So I'll just call it X, or if you want to call it some other letter, you can. So a number, what's decreased mean? Minus. So a number decreased by 4, or minus 4, is less than 14. I'm going to come back up here for just a second. Okay. Is less than, my arrow's pointing to my side that has X. So there's my is less than 14. And I've made my expression. Again, we're not solving right now. Right now we're just setting them up. But that's the type of thing we're going to keep working at. So let's see here. 40, okay, is no greater than. All right, let's see here. No is no greater than. Arrow is pointing at my X. All right, arrow is pointing at my X with the line under. Then the difference, what's difference mean? Difference is minus. So the difference of a number and 2. I'm just following along, reading it like I'd read any sentence. Nope. Right now we're just writing down what the problems would look like. No solving yet. That's coming in a couple of days. Oh, bless you. Last one on this side. And again, you've got to keep getting used to the words. If that's the struggle for you, just keep the note sheets out. That's all you've got to do. So let's see. 5 more than, okay, so I'm adding 5 to something. 3 times a number. Okay. Now, I can write that as 3x plus 5, or I can even write 5 plus 3x. Okay, they're the same. There's that is word again. Is at least, let's see. Is at least up in my chart. Goes to the right. And we've got 95. So again, let the chart help you figure out the symbol and what way it goes, and we'll go that way. Let me flip over here for a second. We'll do a few more back here. Okay, let's see. Let's get into some of these that are more like word problems. So let's see, it's number 13. If Sarah gains 6 pounds, she will weigh more than 113. How much does she weigh now? Okay, we still want to be in setup. If you gain 6, that's plus. Okay, so Sarah plus 6, or you could use x, weigh more than, okay, and if I flip back over to the front, I'd see more than, my arrow is eating my variable, 113 pounds. Okay, how much does she weigh now? If I wanted to solve this right now, I'd just minus the 6 to both sides, and I'd find out. But again, right now, I just want you to do setup. And that's it, that's it, that's it. So I'm not worried about these secondary questions right now. How much did that? No, I want this. Okay. 2 more. After Mary paid $8.36 for a CD, she had less than $2.50 left. Okay. Mary paid $8.36. Okay, so there's Mary. If you pay for something, would you be adding or subtracting that to what you had? Subtracting. Okay, so she paid $8.36. So whatever she had, minus $8.36, she had less than $2.50 left. And I could use that if I wanted to calculate how much money she had before she bought the CD. So again, don't overcomplicate this. Just kind of read it left to right, and we're making a sentence out of it. And again, we're going to keep scratching these second questions on this one for right now, because I just want you to get used to writing these. All right, last one. 17. Mac paid less than $5.10 for a package of 3 golf balls. Now this one's kind of interesting. Mac paid less than, you're like, okay. Now $5.10 for 3, which means that it'd be $5.10, but I'd be dividing it by the number of balls in the package. That one was kind of tricky, but most of them won't set up that bad for you. So that's all we're doing on these. Okay. Whole goal, set them up, use the chart, done. And again, your goal is to get done with the evens on this sheet. Okay? And that's it. Now the one other thing I want to do today, and there's only one. Let me switch over here. What we're going to do is we are going to take a look. I'll take this part off in just a second. This one that says solving linear equations, but it says notes up at the top, that's what we're going to be looking at next, because I changed things up a little. And we are going to take a look, to get things a little bit different here, at how to do the notes without necessarily, yeah, the one that says notes up at the top. We don't want the one that says worksheet 1. We want the one that says notes. Huh? No, because the other one's the homework. Why would I give you something to just throw it away? That wouldn't make a lot of sense. Well, I'm not him though. So, what we're going to do is I'm going to start to change things up occasionally. And instead of you having something to see exactly, I'm going to try and make it a little nicer. So when we're trying to solve equations, and we're just going to start with add and subtract today, just a little bit of a start. So to solve an equation, what we're going to do, all right, is we want to isolate the variable or get it alone. Now you don't have to write all of this on your sheet where it says to solve an equation means. Hi. Even if you just wrote to get it alone, thank you, that would be okay. Because again, understanding what solving means is as big of a part of doing algebra as anything. Okay? Because we're used to getting something like this where it says x equals 5 is solved for x. You're like, well, duh, when it's x in a number, it's solved. What we don't think about sometimes is I can have something like y equals 2x minus 1, which is solved for y, because y is alone, but it doesn't mean it has to be a number every time. So that can be something that can change things up a bit. And again, just write down the stuff that you feel you're going to need to kind of look at later and have this available. This will be available online too in this form if there's something you're not sure about. Okay? So you're like, okay, I get it. Variables on a side, that means it's solved for. So what's that going to mean for me? Because I've dealt with this equation thing before. I didn't have a whole big joy with it. So what do? Well, now, before any of you start to write this down and go, yeah, I'm lost, I'm done, shutting it down. This addition property of equality, what's up with that on this? Well, basically, here's what I'm getting into. I can take any number, and if I add it to both sides of an equation, the equation's still true. So if this whole deal up here is like, yeah, that confuses me, then don't write this part. Just jot down something with the bottom, which means like if I know that 5 equals 5, you're like, again, duh moment. Well, what if I add 4 to each side? Well, they're still the same. It'd be 9 equals 9. And that's what I'm trying to get through with this right now, is the idea of understanding that if I add or subtract something to both sides, it's the same still. And that's where the whole idea of equations comes from. So let me get something a little more real example like going for you here. Okay? We know that 7 equals 7. Okay. Does 7 plus 4 equal 7? No, because I only added the 4 to one side. That doesn't make any sense. Okay? We know that that'd be 11, and 11 doesn't equal 7. But we do know that if I add 4 to both sides, the two sides are still equal. Now that's a real basic. You're like, there's no variables there yet. But the idea is the same, because variables just stand for numbers anyway. So the equation was still true when I went from 7 equals 7 to 7 plus 4 equals 7 plus 4, because I added the same thing to both. Now, again, some of you will think I'm weird with some of these examples I use, but that's okay. Because this is kind of the way I look at equations. Would you leave the house with only one shoe on? I hope not. Oh, I hope not. Okay? Or would you just put blush on one cheek? Or would you just shave one side of your face? It's the same idea. Whatever you do to one, you need to do to everything to make sure everything looks right. Okay? It's the same thing with math. If you only do it to one side, or you do different things to different sides, that's going to look kind of odd. So it's just something that you definitely want to watch out for and keep an eye out on. So, if I had something like x minus 6 equals 10, I want equality. I want to know what x is. I want to isolate the variable. How do I get rid of, or what's the opposite of minusing 6 to something? Adding 6. Okay? And whatever I do to one side, I have to do to both. I can't just add 6 on the left because that's where I want to get by itself. I need to work on getting going with what's going on to be able to get x by itself and get to my answer. Okay? And that's all we're ever going to be doing with these. It's all about equality. It's all about one side equaling the other. So then, now, do you always have to check your solution? No. But the nice thing is with having a calculator, it's not real hard to. because all I would have to do is take my problem that I started with and plug in the 16 where the x goes. And if I find out that 16 minus 6 is 10, I'm good to go and I know it. And that is true. 16 minus 6 does equal 10. And I still have the equality. I still have the two sides that equal each other. So it's not real hard to check that out. But will there be some tricky moments? Yes. Okay. If we get y plus negative 4 equals 9, my first thought might be, ooh, I see plus, so I have to minus the 4. But we have to remember that y plus a negative number is the same thing as y minus 4. And whenever I see the double symbols, I'd rewrite it with the minus, because if you do, it's going to make life a whole lot easier to work with. Because now if I know it's minus 4, now I can use my opposite. The opposite of minusing 4 from something would be to add the 4. Again, it's just one quick step of doing an opposite. And that's all we're trying to do here. So once I do that, oh, my 13 ain't showing up. It does say y equals 13 underneath my... But that's what we're trying to do. And again, once I know or I think my answer is 13, I just plug it back in. Does 13 minus 4 equal 9? It certainly does. And then I know my answer is right, and I go on. I don't even need the key to be able to check that and make sure that everything is right. Like, ooh, man, Harty, you just got to keep throwing all the weird stuff in here. Okay. Negative 16 plus z. Again, I always got to remember to use the sign that's in front of my number. So here, even though I see a plus, what sign's in front of it? Well, a negative is. So I got to do the opposite of a negative 16. And we're going to add 16 to both sides. Because I need the negative 16 and the positive 16 to cancel each other out, because again, I'm trying to isolate. I'm trying to get the variable by itself. And then I just do 16 plus 7. Let's see if I get on the screen this time. Of course not. Is 23, since you can't see that last little part there. And again, that's all I'm trying to accomplish here, is to get my variable by itself. And I can plug that into the calculator if I don't know if negative 16 plus 23 is 7. Because when I do plug it in, it works. Ooh, trick questions already. All right. Negative 10 minus n equals 5. Okay, let's think about this for a second. I want to get n by itself right here. What's the opposite of minusing 10 from something? Adding 10. Okay. So we've got that part. Is my n isolated? Is it alone? Not quite. Close. That negative's a problem. We need n to be positive. So, since the opposite of n, because that's what negative means, is positive 15, I can just switch the signs on these. I can make the negative n positive, and I can make the positive 15 negative and get my answer that way. So just make sure every once in a while, okay, so my solution's n equals negative 15. And again, I could plug that into my calculator as well. I just have to have the negative minus a negative here. And that'll be the tricky thing to remember that, oh yeah, it's minus and a negative here. What happens when you minus a negative? It becomes positive, so it becomes 15 minus 10, which does equal 5. I was thinking ahead here. So 15 minus 10 equals 5, so we're right. And we've got the right answer. So again, not too shabby. They're like, oh, it's the fancy stuff again. Okay? And I'll run through these a little bit quicker. Subtraction property of equality basically is the same idea as adding was. If I subtract the same number from two things, I keep the answer the same. So basically, same rules apply, except now it's minus instead of plus, is what I'm trying to get to here. So when I do these, because you're like, okay, Harty, we already did plus. Why are you doing plus again? Because again, now with it being plus 3, my opposite's to minus it. And again, checking for you is always going to be optional. I will never force you to check. But I'm sitting here going, shoot, if I know I have the right answer by checking it, why wouldn't I want to do it? Okay? So I do my opposite. I do the same thing to both sides. I get my answer. Okay? Does 14 plus 3 equal 17? Because I plugged the 14 in for x. It absolutely does. So when I get to this next one, I want to get y alone. How do I get the positive 13 out of there? What's the opposite of adding a positive 13? Yeah, subtracting it. Okay. I'm just doing opposites. Keep life simple on yourself. And then you can always just ask yourself the question in the end, is 13 plus 7 equal 20? It certainly does. Oh, the infamous double negative. Again, whenever you see the negatives right next to each other like this, that really means plus, because two negatives make a positive when we're adding or subtracting like this, okay? So minus a negative becomes plus. And then again, I just do my opposite and subtract. You're like, okay, the same thing keeps happening. Right, that's the idea. That's the nice thing about math. Same thing tends to work. And that's all we're trying to do here is get you some examples for this. And when we get to the next quiz, if you need this to give you a little assistance, I'm good with that. And again, that double negative makes it plus, like we've mentioned before, and yes, it works for us. Just keep life simple. And again, this will all be there, and we're always going to have that back as review. And then there's a few, if you want to try on your own, you can. I'll pop the answers on the next slide here in a little bit if you want to be able to check those. But otherwise, here's sort of what I have on tap for you here, what I want you to try and do. So again, like I said, we're not doing the whole packet on the notes or the worksheet stuff today. What I'm going to do, and like I said, I will come back to this in a minute. I want to come back to where we are here. Okay. The one other packet thing that you have that we haven't touched yet is right here. Okay, this is the last assignment in homework check 2. So what you're going to do is on this first sheet, okay, just the front, there's not even a back to this first sheet. This is the sheet we're going to work on and have ready to go tomorrow, because tomorrow we're going to kind of keep adding to this. Some of you are like, okay, this may not be too terrible, but I see some things I don't like. I see fractions, and then I start seeing word stuff down at the bottom. What's up with that? Well, here's what's up with that. Let's chat about this. Let's take a look at number 8 and number 9 together to give you a little bit of a kickstart. And then I'll let you kind of work on these on your own for about 10 minutes, and I can come around and see how things are going and see if there's any issues. But here's what I like to do with equations. Whatever variable I'm trying to get by itself, I like to box in because it reminds me, okay, that's got to be by itself for me to be done. Whatever is not in the box has to go away. So, W is in the box. Minus 5/8 is sitting outside here. How do I dump minus 5/8? What's the opposite? Plus 5/8. You're like, yes, but Harty, there's still a fraction involved here. Again, I understand. Those cancel. So I'm just down to W. That's awesome. Here's what I would suggest for some of you if you're having issues with fractions or think you do. Here's how they work. Whenever you're adding fractions, if the number on the bottom, your denominator is the same, we leave that part alone. We don't touch it. It just stays 8. But I do add the numbers on top, which is 10/8. Now, if you left it that way, it's pretty much right, but it's not perfect. You're like, oh, so what's perfect going to be? Well, here's how we're going to do perfect. We're going to let the calculator help us finish this off. You're like, I'm not sure. 10 over 8. All right, let's see here. 10 divided by 8. If you want to see if it reduces any further, we just hit math and enter twice. So if I do math, enter, or most calculators these days will have some sort of a button on there to simplify things. But our calculators in here, all of them do. And you're all on the checklist there, so you've all got a calculator available. And I can get to my answer. Again, it's okay to use the tools that you have, but in a problem like this, I don't want decimals. Because decimals are just going to get us into some bad habits and take us down some bad roads. We don't want to go there. Define a variable, write an equation, and solve. All right, we can do this. A number, all right, increased by 5. I'm just going to read it like I'd read a sentence. Is equal to 34. Find the number. Well, now we can. Because we know, oh yeah, I want to get x by itself. Now box it in. So what's my one step now to get x by itself? Minus the 5. Perfect. X equals 29. I've got my answer. So again, your job for the rest of today into tomorrow when you come in is to finish this first sheet in our worksheet 1 for adding and subtracting. Okay, this is our 6th assignment here. And then also to finish your evens there. Okay? And if you're having issues, let me know, or even in the morning.